Good morning, my Algebra 1 students. I hope you guys are having a fantastical day. So today we're going to go ahead and get started. We're going to do lesson 7.4, division properties of exponents. So far we have learned how to add using exponents and when we're multiplying, and now we're going to be using division properties of exponents. So for today's lesson, you're going to need paper, pencil, just a calculator, and again, you can use that calculator.net. For that free online calculator, you'll need your textbook, page 439. You have homework 64, which is lesson 7.4a online. And this homework is not due until Wednesday at midnight, so please make sure you use your time wisely on this. So we're going to go ahead and we're going to get started. So we're going to go ahead and teach you the rules for dividing powers that have the same base. So same base means they both could be 2s, they both could be 4s, or their bases could be the same variable. So in our case, our variable is going to be a. So now we're going to divide. So here's the dividing bar. So now we know they both have the same base, and that base is a. So we're going to give this exponent an m and this exponent an n. So now they've got, sometimes they might have the same exponent, sometimes they don't. But the rule says when they have the same base, we keep that base, whatever it is. When multiplying, we added exponents. So the opposite of multiplying is dividing. And so the opposite of adding is correct, subtracting. So instead of adding the exponents, we will subtract the exponents. So I'm going to show you how to do this with both numbers and variables, and then we'll kind of build on this one. So we're going to start off with doing, say, 2 to the 6th divided by 2 to the 2nd. And then we will try x to the 4th divided by x to the 7th. And then we're going to do s to the 3/4 divided by s to the 1/2. So we're going to show you 3 different situations of what you will have. And again, you can use your calculator to help you with your subtracting, especially if you don't comfortable with the fractions. Alright, so if they have the same base, we keep that base. This base is 2. And this base is 2. It means their bases are the same value, which is 2. So we keep that same base. Then we take their exponents of the top, which is 6, and we minus the exponent of the bottom, which is 2. So 6 minus 2. It's not bigger minus smaller. It would be top minus bottom. So numerator exponent minus numerator exponent. So 2 take away 6 is 4. Since 4 is a positive exponent, this is our final answer unless they're asking you to simplify lower. Right? So again, we're going to take our base is x and our base is x. They have the same base, so bring down that same base. Take my top exponent to that base, which is 4, minus the exponent to my bottom base, which is 7. Then I subtract. 4 take away 7 is a negative 3. Remember from our previous lessons, we cannot have a negative exponent, so we have to bring that down to the bottom to get a positive exponent of 3. Since that coefficient is 1, the top stays 1. So this is my final answer. Our rule is going to stay the same here. My base is s, and my base is s. So I bring down my common base, which is s. I'll bring it down here. I have room to write my fractions. So my top exponent is 3/4. Minus my bottom exponent, which is 1/2. So we're going to break out that rusty trusty calculator in case you don't want to do these by hand. So I'll bring it up here. So I'm going to do 3/4, so 3/4, and then I'll minus out 1/2, and then I will get 1/4. So this becomes s to the 1/4, and 1/4 is positive, so this would be my final answer. All right. So these are the rules for when you divide with exponents, you are going to subtract the exponents. So we're going to go ahead and move on to example 1, which is on page 440. So we're going to be on page 440. And we're going to do example 1. I'm going to go ahead and write down 5 problems for us, and then I will resume our video. Okay, hang on. Okay, So these are the 4 problems at the bottom of page 440, or top of page 440. You'll see got it 1. What is the simplified form of each fraction? And here we have 5 examples, A, B, C, D, and E. So example A, B, C, D, E. And I'm going to show you each of these, and I encourage you to take notes so that you have examples of what to do. So remember, the rule for dividing with the same base is we subtract their exponents. So we first identify who has the same base. Base y, base y. So they have the same base, so y. And then we take the exponent for the top base, which is 3/4, and we minus the exponent to the bottom base, which is 1/2. So break out that rusty trusty calculator, which we just did a second ago. Bring it down so you can see it better. 3/4 minus 1/2 is 1/4. So this becomes y to the 1/4. We do not have any negative exponents, so this is our final answer, y to the 1/4. Alright, so we're going to move to the next one. Our base is D, and our base is D. So they have the same base of D. So take the top exponent, which is 7/2, and I minus the bottom exponent of the same base, which is 3. So to break out the old rusty trusty calculator, we're going to do 7/2, oops, 7/2, and then minus 3. And then hit our equal button, and we get 1/2. So this becomes D to the 1/2. And again, my 1/2 is not negative, so this is my final answer. Alright, so we're going to move to the third one. So look, I have 2 variables this time. So only the ones that have the same base. So this is a base of k and base of k. So I'm going to start with just the k's. The k's top exponent is 6 minus the k's bottom exponent, which is an understood 1. So 1. Then I'm going to do the j, so base j and base j. Its top exponent for j is 2 minus its bottom exponent, which is 5. So again, there are 2 different bases, base k and base j. So we subtract the base k's exponents together and the j's exponents together. So 6 minus 1 is 5, so k to the 5th. And 2 take away 5 is -3. Well, we can't have a negative exponent. My k to the 5th has a positive exponent, so it stays right where it's at. So then my j moves to the bottom to get a positive exponent of 3. So now we have no negative exponents. Final answer. Alright, so we're going to go ahead and move to the fourth one, I'm sorry. Here we have 2 variables again, a and b. So we're going to first deal with just the a's because they have the same base. So a, take its top exponent of -3 minus the bottom exponent of 5. Then we take our next base, our next variable, which is b's. So base b's, top exponent is 7 minus the bottom exponent of 2. So we're going to go ahead here. This is our ones that have base a's. So -3, take away 5 more, makes -8. And then we got our base b's. 7 minus 2 is 5. We have a negative exponent of -8. So our b has a positive exponent, so it stays put. The a has to drop to the bottom to get a positive exponent of 8. So this is our final answer. Alright, so we're going to move over to our next one. All right. Y and z. So you start with one variable at a time. So the first variable has the same base of x, so bring down the x. And its top exponent is 4 minus its bottom exponent. The next variable we have is a y, so base y and base y. Its top exponent is -1 minus its bottom exponent, which is a -5. And then we've got our third and final variable, which is z, so base z. Its top exponent is 8 minus its bottom exponent of an understood 1, so -1. So you can't forget, you can't pretend like the 1 doesn't exist, and you can't add 1 when there isn't 1. So if you have 2 numbers, you just put 1 in there. You have to use the numbers that are there. And if you don't see a number, then it's an understood. All right, so we got 4 minus 4, which is 0. And then we have negative 1 minus minus. So this is the same as negative 1 plus 5, because a minus minus makes a positive. So negative 1 plus 5 is 4, and 8 minus 1 is 7. So here we have an x to the 0 power. So anything raised to the 0 power we learned previously is equal to what, Cheyenne? Correct, that is 1. So this is the same as 1 y to the 4th z to the 7th. We really don't need the 1 out front. So it's just y to the 4th z to the 7th. Final answer, because our 1 is an understood 1. Alright, so we're going to move to our final example, and this lesson will be just about over. Alright, so now we're going to teach you how to divide using scientific notation. So just like with multiplying, we would always multiply the two constants first, and then we would deal with the things that had the base 10 second. So we're going to do the same rule. We're going to take the numbers out front, this 1.21, and we're going to go ahead and just divide this by our 4.81, and we're going to get a value, and then we'll follow these rules. So we're going to first take and separate this out. It's going to look like this, 1.21 divided by 4.81. That's what you're going to solve first. Then it's going to be times, and then it'll be 10 to the 7th divided by 10 to the 8th. That's kind of how we're breaking this apart into two different components. So you break out your rusty trusty calculator. You're going to put 1.21, and you're going to divide it by 4.81. You can hit your equal button, and we'll change it to a decimal for me. You can see I get this long behind answer. So what I'm going to do is round to the nearest thousandth, which is going to make it 3 decimal places. So tenths, thousandths place. So here's my 1. It's the thousandths place. So again, tenths, hundredths, thousandths. I look to the number to the right, which is a 5. And this 5 is 5 or larger, so rounds this number 251 up 1 spot to 252. Approximation here. So this is approximately 0.252 times. We're going to keep our bases. Remember, our bases are the same. They're 10. So we take their exponents. Top exponent is 7 minus the bottom exponent, which is 8. So the rules are not changing from what we did a second ago. So now we got 0.252, and then 7 take away 8 is negative 1. Alright, so now what we have to look at is we currently had our decimal spot here. This is where our decimal is. It's gone over, it's like saying 10 to the negative 1 means we started somewhere on the left and we moved it to the left 1 spot. But I need to take this guy and I need to move him more. Well, this is not an 8, guys. I'm sorry, that's a 5. That's going to change our values. Oh my Lanta, for the love of Liza. So 7 minus 5 is 2. Okay, I'm just going to scratch all that out. Sorry, I can't read my own handwriting. This is a 5, so 5, 5, and then 7 minus 5 is 2. My bad. We'll clarify that all down here because I'm a ding-ding. Alright, so that means we moved our decimal place. It started over here somewhere, and it went over 1, 2. I went too far. So I have to take this little guy, and I need to bring him back to the right spot. Means this decimal should be here. It should be 2.52 times 10 to the something. So since I have to bring it back 1, I got to subtract 1 from this 2, which makes it 10 to the first, or just times 10. So this would be my final answer right here. Alright, and then if I solve that out, 25.2, so this would just be scientific notation. Alright, so let's do the same thing here, and hopefully I can read my handwriting, and y'all be forgiving of me. Alright, we're going to take the first part, which is 5.2, and we're going to divide it by 1.3. First step. So we're going to break out the trusty calculator. We'll clear this out. I'm going to do 5.2 divided by 1.3 and hit my, oh, perfect, it's a 4. Look, I don't have to do any rounding. So this becomes 4. And then I got times, and then I've got 10 to the 13th divided by 10 to the 7th. Alright, So since they have the same base of 10, I take my two exponents, which are 13 and 7, and I subtract them. So 13 take away 7 that is correct. It is 6. This is in scientific notation because my decimal secretly hides out to the right of every whole number. So there it is. It goes to the once you find your whole number, if you don't see a decimal, you go to the very far right of that number, and that's where your decimal secretly hides out. Well, since I only have one number, my decimal is to the right of that number, this is scientific notation. I am done. Although I don't need that decimal. Not needed. If you put it in Math Excel, it's going to mark it wrong. Alright, so we're going to move on up and do these last two, and this will be the end of our lesson for today. So we're going to take our first two parts, which is 3.6, and divide it by 9. So bring out old Rusty Trusty here. We're going to do 3.6, pull this down a bit, 3.6, and divide it by 9 to a decimal, and I get 0.4. We'll write that down, 0.4. Alright, bring down my times symbol. So I got 10 to the negative 10 to the negative 10 over 10 to the negative 6. Alright, so since we have both our base 10s, we bring down the base they have, which is 10, take the top exponent negative 10 and minus the bottom exponent, which is negative 6. Right? We've learned that the negative is a, that's right, positive. So it's the same as negative 10 plus 6. Let's bring down my 0.4. And then negative 10 plus 6 is negative 4. Alright, so my decimal, when it's negative, it started over here on this left side, and it went over 1, 2, 3, 4 spots. But my decimal's not in the right spot. My decimal should be on this side of my 4, which means it needs to move an additional 1 spot more, which means I need to go over 1 more. This is over negative 4, and 1 more would make negative 5. So this would be times 10 to the negative 5th. And again, you do not need this decimal typing in your Okay, so now we're going to move to our final one. So we take the two numbers, 0.5, we're going to divide it by 5. Break out old Rusty Trusty. Clear this out, 3.5, I'm going to divide it by 5. I'm going to change it to a decimal for me, so 0.7. 0.7. Bring down my times symbol. The bases on the back end are 10, so 10 to the top base minus the bottom base, which is 8. And 6 take away 8 is negative 2. So this means I move my decimal, negative 1, negative 2, to get to here. But my decimal should be here, so it needs to go over 1 more, so this would be negative 1, negative 2, negative 3. This should be times 10 to the negative 3. I had to go over 1 additional spot to the right. Alright, so this is our scientific notation. This is the end of the lesson. If you have homework online, please make sure you take time, watch through your video, re-watch again until you understand. And again, the homework is due on the 29th at midnight. Have a fantastical day.